Okay, hello everyone. My name is Karima Boris. I am, as everybody knows, I am a Chabot College student right now, and I'm enrolled in the Electronic System Technology class. And today we are presenting our project for ESS 61 class. The project name is Smart House. So it will be presented by me as the team leader, and my other team work will present themselves.
Hello, I'm Tommy Robbins, and I was the prototype technician for this.
My name is Josh Cabello, and I'm the portfolio person.
Okay, cool. And before I go to the purpose of our project, I would like to make a small introduction to our project. So I will start by defining what is the smart home. A smart home is defined by the collaboration of technology and services for the home, and by the collaboration and the home and services through a network for a better living condition. It will allow the entire home to be automated and provide an easy access to all your home appliances. So for our project, what is the purpose of our project? Our project sets out to demonstrate the advantages of smartifying your home by showing up something as small as a single board computer like an Arduino Uno, and a smartphone can manipulate various household appliances through a scaled down diorama. So for the purpose, what is the purpose of our project? By using a special app on your smart device, you can control many electrical and electronic appliances with a few taps of the finger. Turn the lights on and off, dim them down to set the mood, and crank the AC all the way up during a hot day. Our project offers a small taste of what is possible with today's technologies, just as on a smaller scale. Okay, and for the diagram, I will pass that to Josh.
Okay.
All right.
Oh, Karima, you have to end your share screen.
Okay. There you go.
All right, can you guys see my screen?
Beautifully.
Yes, okay. So this is a rudimentary diagram of our project, but in short, it's basically an Arduino and a Bluetooth module. In our case, it's an HC-06. And we're going to connect it to a few devices. So we have a lamp here in the top right, as well as a fan in the top left. And down here is a makeshift door that we're making out of cardboard. And we'll lock it with a servo. And what the Arduino will be able to do is it will sense whether or not that door has been locked using these two LEDs here. Now, let me pass this off to Tommy, and he can show you a little more about what the project will look like.
Okay. One moment. So here is the project. And then here is the phone. If I tap this, it will turn the fan on.
Oh, Tommy, I think you're on the wrong screen.
What?
Oh, never mind. I see it.
Okay. If I tap this, the fan will turn off. This will turn the light on. This will turn the light off. Now for the tricky one. If the door is open, like this, the lock will not activate, but if the door is shut, it will activate. There we go. And then on the inside, it will also have a red LED showing that it's locked to the person inside. And here is the relays. The Arduino. And the breadboard with the Bluetooth. And then I will go on to the procedure and materials we used. We used Arduino Uno, jumper wires, light bulb, lamp socket, breadboard, DC fan, voltage regulator, 1K ohm, 2K ohm, and 220 ohm resistors, relay, servo, LED, 9-volt battery, cardboard box, aluminum foil, and Bluetooth HC06. The first step, if you would like to recreate this project, would be to download a Bluetooth controller from your app store on your phone. Step 1 is to find yourself a good cardboard box. Step 2 is to cut a hole on one side, leaving one of the other sides of the hole uncut, and then cut a smaller hole on the different side using the same technique. Make sure to cut at an angle so the top part won't fall through, which I did not do that, and so I have to secure it every once in a while with another cardboard piece. And right here is the door with the servo. And here is how the Bluetooth module is wired up with the different resistors to the receiving. And then put the servo included with the circuit of the Bluetooth module, and you will be able to control the servo through your phone with the Bluetooth. And then put it inside the box. Make sure to tighten down the lamp and fan to the box so that they do not fall off. Connect everything to the relay module, and be careful when wiring the light because it is 120 volt source. And then the code is right here. Next, test everything out, including the fan and the lights. And then for the door sensor, it is a makeshift door sensor where we have aluminum foil on one side of the door and aluminum foil on the other side of the door. And so when the door is shut, it closes the circuit and it sends a signal to the Arduino letting it know. And that is the procedure of our project. Now it is, I believe, Josh's turn.
Okay, let me share my screen again. Okay, so you may be wondering what you could do with this project, and in reality, it's actually nothing new. In fact, even before the internet was created, people have been trying to invent a fully automated home. A kitchen, for example, would have a complex set of machinery that could automate the process of cooking your food. It could chop meat. It could also boil water for you without any need to do it yourself. Nor would you have to monitor any of it, which is the same sort of concept as a smart home would be. And today, it's actually possible to do all this with something as small as an Arduino. In fact, I believe a Raspberry Pi, as you can see here, this project, this technology here called CM3 Home is actually using just a regular Raspberry Pi to control an entire house. All right, now let me pass it back to Karima, and she'll be able to tie this up.
Okay. All right, so for the data that we used, pretty much we used this code for the servo motors, and one for the light bulb and the fan, and for the entire project. So each one was, it's in the Arduino library, and it is, yeah, it is downloaded and pretty much, yeah. For, where is that? This is my other applications. Hey, Josh.
Yeah?
I don't see here the appliance, the conclusion and works cited.
What?
And I mean the analysis and conclusion.
You hover over the arrow, and then you click either analysis and conclusion or works cited.
Yeah, I don't see it here, so I will pass it for you. I only have applications and works cited.
Yeah, that's odd. Okay.
We see it on our screen, Karima. We can see it. Just go above applications and click whatever space is above application. Or go back to more, and then right above applications, hit whatever space is above applications.
Yeah, I don't see it here. So I see my name here, and I cannot click on that one. Yeah, as you can see.
Okay, that's odd.
Yeah, I can't.
Okay, yeah, just pass it back to me then.
All right, I'm sorry for that. Yeah.
You can pass it back to Josh, and you can continue chatting once he has the appropriate frame on the screen.
Yeah, I will pass it to you, Josh.
Okay. Okay, that should be the works cited page right there. Would you like to narrate over that, Karima?
Okay. All right, if you go back to the analysis and conclusion.
Right here?
Yeah, I'm gonna do the analysis, yeah. So for our project, what we worked on this project, we had good heavy issues when it came to getting it completed. So first of all, we did not have much time to do all of that because of the time frame and other classes. It was a busy thing. And then what else? We took a long time for us to get our parts in and had to rush to build the process. The other thing, they gave us the wrong Bluetooth module. Yeah, when we got the stuff delivered, instead of the Bluetooth A05, they gave us the 06. What else? It was a big challenging to communicate with Tommy, since he's having a prototyping issues, and we cannot be there physically to help him out. Yeah, and what else? I did the door sensor as afterthought, and then but it worked actually at the end of the project. And yeah, for the works cited, Josh. For the works cited here are the links that we use to make our project done. First, some of them is how to make the smart home by Arduino, and the other ones by the library, and the other ones is home automation using Arduino. Yeah, it's a bunch of links that we use to get this project done. Yeah, and then another site is using the HC5 Bluetooth module links. Yeah. Right. And then by that, I think we covered everything in this presentation.
Any questions?
Questions from the classmates?
You never mentioned the total cost. I had my money. What's going on? What's the average cost of your total device?
$44K.
$44K? Is that? This sounds like a random number. I don't know about that one.
It was properly calculated after factoring in the budget, the materials used, as well as the time labored by each of us.
Of course, we'll see that itemization in your e-portfolio.
Yeah. I might need a receipt for that one.
Any other questions for the team? Okay, in conclusion then, what most important learning takeaway you have from this particular project? So whoever would like to go first, I'm looking for 3 responses.
Yeah, I will go like first. So what we learned from this project, it was a good experience to work with Josh and Tommy. And even though we cannot be gathered and do the project physically all together, but we came out with ideas and we contacted each other and we get the project done. It was a good experience to work as the whole team.
Thank you, Karima. And Josh and Tommy?
I guess I'll go next.
Okay, go Josh.
Yeah, so it was really hard for me to do this because the way I learn, I have to be in person. I can't really do this stuff where there's no one else around because then it feels like I'm missing a lot of things. Like we're not really on the same page, but we were able to get this done.
For my learning objective is I was having issues with the Bluetooth module, and I was going through all these forums checking out what may be the problem, but I should have been actually checking my wiring, and because I ended up wiring the transmitter and receiver backwards, so it was my fault. So I learned that I should check my work more than, yeah.
That's a good takeaway lesson. I will say in summary, great work, great project. I in particularly liked how you came up with the door sensor, that the 2 parts of the aluminum foil coming together, making contact when the door was closed, was the command given to the Arduino that the contact was closed. Therefore, then and only then was the servo motor able to be controlled to lock the door. And visually, it was very, the point was made quite visibly with the latch, if you will, of the servo motor arm coming down in front of the door so that the door could not be opened from the inside or the outside, as that servo arm acted as a latch. So the mechanism by which you came up for a sensor for the door being closed or not closed was a very elegant solution. So I commend you guys, or Tommy especially, for that. That came up as a an add-on project, yes?
Yes.
Nice. Okay, fantastic. All right, let's, no more questions. Let's give our teammates a round of applause. Well done, well done.